Walang sound to. Okay, magandang gabi mga kapwa kong Marino at Mamamayang Pilipino. Nandito naman si Engineer Ben Lorque magpahiwatig sa inyo ng tungkol sa marine engine operation, tungkol sa starting, running, stopping, at mga terminologies used for engine power, generator fuel oil consumption per hour at different load, at saka proper bunkering operation procedure sa barko. So sa mga gusto magmarino, sa mga datihan na marino na alam na nila ito, hindi siguro na nila kailangan, ngunit sa mga baguhan o sa mga nag-aral at saka bago tapos sa pag-aral sa marine engineering, napakalaga ang tapiko na ito sa ngayon. So simulan ko na ang tungkol sa marine engine operation sa barko. So for various type of main engine of ships, it is important to carry out the proper check, take necessary precaution, and maintain parameter for trouble operation. Good watchkeeping and maintenance result in high efficiency, fewer breakdown, and smooth operation. In this, we will go through the generalized and most important point for all types of engine. So ang i-discuss ko ngayon is preparing to start the ship main engine. So ito tandaan niyo na before starting the main engine, the following check procedure are to be undertaken. All components that have been overhauled are to be checked and whenever possible, function tested. All equipment, tools, and rugs used during the overhaul are to be removed from the engine. So 1, air system. About air system, you have to drain the water present in the starting air system. Then drain any water present from the control air system at the reservoir. Pressurize the air system and ensure that the pressure are correct, and ensure the compressed air, is available at the exhaust valve, air spring, closing cylinder. And then when it comes to lubrication, you have to check the oil level of the main engine sub-tank and replenish if it is necessary. So start the engine lobe oil pump and the turbocharger lobe oil pump. You have to ensure that all the oil pressure are correct. Ensure also that there is adequate oil flow for the piston cooling and turbocharger. And check the oil level in the cylinder rub oil tank and that the supply to the lubricator is open. So check the cylinder oil flow meter is properly functioning and note the counter of the flow meter. Then after checking the low oil, you have to check the cooling water system. So you have to make sure that the main engine jacket are under normal circumstances, that the main engine jacket water is continuously circulated through the preheater during the stay in port and are never allowed to cool down. You have also to ensure that the cooling water system pressure are correct and that the system are not leaking. Check also that the engine is at its correct operating temperature. Then check the level of the expansion tank and evident decrease in the water level in the expansion tank indicate leakage. So if there is leakage, you have to replenish the expansion tank. So the fourth system is you have to slow turning the engine with the turning gear. So slow turning of the engine must be carried out to prevent damage caused by fluid leaking into any of the cylinders. Permission from the bridge must be sought before turning the engine. Napaka-importante ito na you have to seek permission from the bridge dahil baka may tao doon sa may propeller o may mga naglalaro ng mga bata kasi hindi mo minsan maiwasan, may mga tao na naglangoy-langoy doon sa ilalim. At pag pinaikot mo ang propeller, matamaan siya. So, pananagutan ng barko yan. So, that is under the precautionary measures. I-check yan ng deck officer kung libre ang propeller bago mo i-turning ang makina. So, after that, then the pre-lubrication should be carried out and always carried out the slow turning operation at the latest possible moment before starting. Then after that, you have to ensure that the regulating handle are in the finished engine or finished with engine position. So ensure all the cylinder indicator cap are open. Turn the engine one revolution with a turning gear. Check to see if the fluid flow out of any of the indicator valve. Alam mo dito may comment ako. Kaya napaka-importante ito nag-turning ka ng makina mo. Tingnan mo ang lubricant. Nangyari sa amin ito sa barko na sinasakyan ko na nung nag-turn ng engine, lumabas ang langis sa indicator valve. So nang check upin ko, nagduda ako na baka may problema ang turbocharger. So nang nag-report ako sa opisina, sabi nila baka ang problema ay sa skirt at saka sa piston crown. Baka ang o-ring doon baka nag-leaking. Ngunit sabi ko kung nag-leaking, bakit lahat na silindro ay may langis? So all cylinder are mixed with oil. So nagduda ako na posible sa turbocharger. Hanggang na sabi ng taga-opisina, magbunot ako ng piston pero hindi ko sinunod dahil as a chief engineer on board, you must know yourself what are happening on board kaysa doon sa mga tao sa opisina. So sa madaling salita, nung pinaikot ko ulit, lahat na silindro may mga langis. So sabi ko okay, tingnan nga natin ang turbocharger. Hindi ako nagbukas ng cylinder head. Naku, nung tingnan ko ang turbocharger ay dami ang langis doon. Kaya pala putol ang shaft ng turbocharger. Although wala pang 30 days na nanggaling sa paradero ang barko, kag mangyari yan. Kaya ang ginawa ng taga-paradero nung mangyari yun nung mag-report kami, hinila nila barko balik sa Bradero. At doon nalaman na ang turbocharger shafting na ginpalit ng taga-turbo at taga-Bradero, kasi bago lang ako nagsampa noon ng chief engineer, kung kami sa Bradero nagpalitan, wala pala sa standard. Luma ang pinalit nila para kasi ibinta ang barko. So, kaya kung minsan napaka-importante na kung mag-turning ka ng makina mo, ang indicator cock, tingnan mo baka may problema ang makina. So, kung may langis o tubig na lumabas sa indicator valve or indicator cock, tingnan mo kung saan ang galing. Kasi pag pinandar mo yan, sabog ang silindro dyan. Kung may foreign matters doon sa loob, either tubig o langis. So next then, you have to disengage the turning gear and ensure it is locked in and out position. So dyan sa ano na yan, may indicator yan. Turning gear in, turning gear out. So kung naka-turning gear in, hindi mo pandar ang makina mo. So make sure that the turning gear is out before you start the engine. So check also that the indicator lamp of the turning gear engaged is extinguished. Then 5, slow turning of engine on the starting air blow through. So permission must be sought from the bridge before turning the engine. So the bridge should be asked for proper propeller clearance. Always carry out the slow turning at the latest possible moment before starting and within the last 30 minutes. Bring main engine to the standby mode. So when you have to go with the standby, so the bridge will have to acknowledge that. So by slow turning the engine, the control has to be taken in the engine room, not on the bridge. Dahil ikaw na makinista doon na nakaalam kung ano ang gusto mo mangyari sa makina mo. So you have to call the bridge, na sabihin mo, okay, we have to try the engine. So as been mentioned, you have to put to standby position, then pag standby, saka ngayon magsimula mag-start. So then you have to slow turning on the main engine operating panel if present, or give a kick from the engine control room by moving the regulating handle to dead slow momentarily. When operating telegraph from the engine control, communicate with the bridge, you should follow the command on the telegraph. So as the engine turns, check to see if any fluid flow out of the indicator cock or indicator valve. So when the engine has turned one revolution, move the regulating handle back to stop position. So close all the indicator cock. Also close the turbocharger drain. The sixth is the fuel oil system. So check the fuel oil supply pump and fuel oil circulating pump. If the engine was running on heavy fuel oil, when stop, the circulating pump and the fuel heater should still be running. So check that the fuel pressure and temperature, check fuel oil flow meter are properly functioning, and note the counter of the flow meter. So as far as miscellaneous is concerned, you have also to check that all the engine instrumentation is reading correctly. If not, check the instrument and replace as necessary. Check that all the cabin's air receiver and drain box are open and that the test cap are closed. Check that the engine top bracing system is in service. Check the thrust bearing temperature and lobe oil pressure is in the range. Check axial vibration damper and torsional vibration damper lobe oil pressure in the range. Check that the fuel leak of alarm is functional, and check that the level of fuel leak of tank to notice any rise in the level later due to leakage, and check that the level of the cabin's drain tank. The tank should not be full or else will lead to overflow of cabin space of main engine, and check that the governor is responding efficiently. So when the normal operation check is done, you have to proceed to, during the normal running check, a regular check has to be made on the precaution to be taken. Regular check of the system and the engine pressure and temperature. So the value read of the instrument compared with those given in the commissioning record, taking into account engine speed and or engine power, provides an excellent data or datum for estimating the engine performance. Compare the temperature by filling the pipe. The essential reading are the load indicator position, turbocharger speed, charge air pressure, exhaust gas temperature before the turbine. A valuable criterion is also the daily fuel consumption, considering the lower calorific value. So check and compare between the cylinder and main indicated pressure, compression pressure, and maximum combustion pressure. Check the operation of the oil mesh detector. So check of the shut-off valve in the cooling and lubricating system for the correct position, and the valve for the cooling inlet and outlet for its engine must always be fully in service, and they serve only to cut off individual cylinder from the cooling water circuit during overhaul. By the way, let me emphasize to you the oil mesh detector, as I previously mentioned. Ang function ng oil mesh detector ay to avoid sudden explosion of the engine. Kasi ang makina, pag mahaluan na ng mga mesh, delikado, magkaroon ka ng explosion. Sabi ng crankcase explosion. So, kaya nalagyan ang makina ng oil mesh detector para pag may mesh doon, mag-alarma yan. So, hindi ka masabugan. Kasi delikado pag nagsabog ang crankcase ng makina at may tao sa labas, nako, sabog din ang tao doon sa labas na na dumadaan o naka-standby. Okay, let's proceed. When the normally high or low temperature are detected at the water outlet, the temperature must be brought to the prescribed value, prescribed normal value, I mean, very gradually. Abrupt temperature can also cause damage. So the maximum permissible exhaust gas temperature at the turbocharger inlet must not exceed. So check the combustion by observing the color of the exhaust gases. So the main and correct charge air temperature after the air cooler with the normal water flow. In general, high air charge temperature will result in less oxygen in the cylinder, which in turn will result high fuel consumption and high exhaust gas temperature. So you have to remember that for every degree of air coming from the air cooler that goes to the engine, the exhaust temperature will also rise. So you have to maintain that at least in hot climate area, the temperature of the air coming into the engine should not exceed maximum of 50 degrees centigrade, if ever possible. So check that the charged air pressure drop across the air filter and the air cooler, and excessive resistance will lead to lack of air in the engine. So the fuel has to be carefully filtered before being used. Open the drain cap of all fuel tank, fuel oil filter regularly for a short period to drain off the water or sludge which may have collected therein. Maintain the correct fuel oil pressure at the inlet fuel injection pump. Adjust the pressure at the injection pump supply manifold with a pressure regulating valve in the fuel oil return pipe so that the fuel oil circulate with the system at the normal delivery capacity of the fuel oil circulating pump. So the heavy fuel oil has to be sufficiently heated to ensure that its viscosity before the inlet to the fuel injection pump lies within the specified limit. To determine that the cylinder lubrication oil consumption, extended service experience will determine the optimum cylinder lubrication or lubricating oil consumption. The cooling freshwater pump should be run at their normal operating point. So that is to say, actual delivery head correspond with the design value. So if the pressure difference between inlet and outlet exceed the desired value, the pump overhaul should be considered. So the vent at the uppermost point of the cooling water space must be kept closed. Check the level in all water and oil tank as well as all the drainage tank of the leakage piping. Investigate any abnormal changes. Observe the condition of the cooling freshwater. Check for oil contamination. By the way, for those who are following me, other than what you hear from what I have mentioned, please
Hi,
also
sir, man.
observe what was being posted in the screen. Then try to make your own hand note para na sakali na doon ka na sa barko, hindi ka mahirapan kung ano dapat gawin. Kasi doon sa salita lang ko minsan, nagkadugtong-dugtong, baka sabi mo mahirap unawain. Pero nakikita mo naman sa screen kung ano ang sinasabi ko. So, take note of that. Okay? So, let's proceed. Check that the charged air receiver drain manifold side glass to see to it to see if the water is draining away, and if so, how much it drained. So check the cabin space test pump to see if the liquid is flowing out in the with the charged air. Check that the pressure drop across the oil filter, then clean them if necessary. So the temperature of the running gears should be checked where possible by listening and observing the crankcase externally and monitoring the oil mesh detector reading. Bearing that bearing that have been overhauled or replaced must be given special attention for sometimes after being put into normal service. So listening to the noise of the engine will reveal any irregularities. The power being developed by the cylinder should be checked regularly and adjustment made via the control system to preserve the cylinder power balance. Centrifuge the lubricating oil. Lobe oil sample should be taken at a frequent interval and sent ashore for analysis. Check the exhaust valve are rotating and operating smoothly. Then if not, the valve not rotating normally has to be overhauled at the next opportunity. Now, securing after engine stoppage. So after the bridge has given finish with engine, switch the engine control to the engine control. Check that the auxiliary blower switch off automatically at finish with engine if they are in automatic. So if it is in automatic mode, so you have to switch to manual and put it off. Or else then it will be switched then off manually. So close the starting air valve of the main engine and vent control system. And good practice is to lock the main starting valve in its lowest position by means of the locking plate. So close the valve for starting the air distribution system, engage the turning gear, and check the indicator lamp. After stopping the engine, wait a minimum of 15 minutes before stopping the lube oil pump if it works. If work is to be undertaken in the crankcase, and this preserves the overheating of the cold surface in the combustion chamber and counteract the formation of carbon deposit in the piston crown. By the way, as far as the stopping of engine is concerned, I do practice that the 15 minutes sometimes is not enough. So after the stopping of the engine, while turning the what we call this the turning gear, you have to run the oil pump for at least 30 minutes. At least 30 minutes. So to make sure that everything inside is cooled down. Kasi kung minsan, kung may mga bagay-bagay doon, may mga parte doon na sobrang init, 15 minutes is not enough. So to make sure that the parts of the engine are cooled down, so 30 minutes is more than enough to observe. So keep the engine preheated to a minimum of 50 degrees Celsius or according to the main engine manual requirement. So if the engine was operating in heavy fuel oil, do not stop the fuel oil circulating and supply pump. If the engine was operating on the medium diesel oil or marine diesel oil, both the fuel circulating valve and supply pump may be stopped. So aware ka mo dito ha. Aware kayo. Kung fuel oil ang ginagamit mo sa makina, never stop the circulating pump and the supply pump para ang circulation ng fuel ay continuous. So pag pinara mo yan, hindi ngayon mag-circulate ang fuel and there is a possibility na mag-stuck ang fuel sa fuel line mo. But kung diesel ang ginagamit mo, yan, pwede mo para ang circulating pump sa supply pump. Then switch off the equipment which is not required during the engine standstill period. So those are the operating principle as far as main engine is concerned. And now let's go to the terminology use of power for the ship's marine propulsion. May mga terminology na kuminsan nakaligtaan ituro sa mga paaralan o sa mga training center. Kaya napaka-importante na doon sa barko, ma-upgrade ang sarili mo. What are the terminology being used? So the best thing about being a marine engineer on a ship is controlling the most powerful things in the world ever created by man, the ship main propulsion engine. So the Wärtsilä Sulzer Artiflex 96C is the world's biggest and most powerful engine ever made with the output of approximately 80,000 kilowatt or 108,000 brake horsepower. Pero mo yan, 108,000 horsepower. Kung ang bridge and Straton ay halimbawa 10 horsepower lang, ito naman ay 108,900 horsepower. Yan kalaki ang makina ng barko. So the overall operation of the ship is highly dependent on the performance of its main propulsion engine, measured in terms of its power rating. There are several terminologies for power rating used for the marine propulsion engine, and each of these given different value of the engine performance under various parameters and situations. Now, kagaya nito, ganyan ang makina ng barko. Ganyan kalaki. So, meron dyan ng mga 5-cylinder, meron 6-cylinder, may 7-cylinder, may 9-cylinder. So, depende sa type and model ng makina. Kaya, napakahirap kung minsan, pag halimbawa baguhan ka lang na wala kang ideya, so, delikado kung magpajakpat ka lang. Kaya, ang training, napaka-importante sa lupa bago ka magsampa sa barko. So following the list of power terminologies used in marine propulsion engine on board, here are the following terminologies which I have to emphasize. 1, the effective power. So this effective power means that the power available at the output side of the engine, that is to say the crankshaft flange of the engine, which connect it with the flywheel and rest to the intermediate shaft. It can be said that this is the developed power by the engine available to the flywheel. So effective power is determined by the engine size and by its mechanical efficiencies. Effective power estimation can be done by two methods. So one is speed and torque measurement using the propulsion shaft arrangement. And second is the engine main indicator pressure measurement using the in-cylinder pressure transducer. And this method is preferred if not the right propulsion unit, and that is to say, gearbox is installed. So the second is the rated power. So what is the rated power? So it is the continuous effective power provided by the manufacturer of the engine for a desired rated revolution per minute or RPM of the crankshaft. So rated power include the load which act on the engine due to the auxiliary system running from the engine power. So one of the most important factor for selection of the engine power, that is to say the MCR or maximum continuous rating, is determined from the rated power. So dito kung minsan tayo nagkaka-problema sa barko. Alam mo kung bakit? May tinatawag na maximum continuous rating output. So doon sa barko, kung minsan pag mababaw ang tubig na dinaanan ng barko, ang torch diyan tumataas. So kaya kung lumampas sa maximum continuous rating ng makina, the engineer has no choice but you have to reduce the RPM, revolution per minute. Otherwise, then magiging problema ang makina mo kung i-continuous mo ang revolution per minute niya sa mataas na ang torque rating niya ay sobra na sa maximum continuous rating na design ng makina mo. The third is the indicated horsepower. So IHP kung tawagin. So the actual power generated inside the combustion chamber of the engine by combustion of fuel is known as the indicated horsepower. So hence it formed the basic evaluation of combustion efficiency or the heat release in the cylinder. So it is calculated based on the design of the engine using the theoretical formula. So even sa high school, ginadiscuss to hanggang sa kolehiyo, kung magkuha ka ng marine engineering, may tinatawag na plan over 4,500, which means P is the main indicated pressure of the cylinder, L is the length of stroke, A is the cross-sectional area of the engine cylinder, N is the speed of the engine in revolution per minute, and 4,500 is the constant for conversion. So ang iba dyan, PLAN over 33,000. Pero dito sa gina-emphasize ko, over 4,500. So in this calculation, the frictional losses are not considered. Since it is calculated from the indicated pressure of the engine, it is called indicated horsepower and is used for calculating the mechanical efficiency of the engine. So the fourth is the shaft horsepower. So the shaft horsepower is the horsepower delivered to a propeller shaft before being converted into thrust by the propeller. It is measured by an instrument known as torsion meter, which is available on board. So the fifth is the brake horsepower. So what is brake horsepower? It is horsepower measured the horsepower of the engine without considering the loss in power that is caused by auxiliaries attached to the engine, such as the shaft generator, alternator, gearbox, and other auxiliary parts. This is the power measured at the crankshaft with the brake dynamometer and is always higher than the shaft horsepower. This is because the power available at the shaft account for frictional and mechanical losses. So the brake comes in as the machine used to measure the power in brake dynamometer. So 6 is the gross power. So gross power is a continuous effective power provided by the manufacturer for a given revolution per minute using defined number of auxiliaries at normal service running condition without any overloading of the engine. The 7 is the continuous power. And continuous power is the brake horsepower measured at the power take off the end when the engine is running at continuous safe operating range outside any time limit. This is provided by the supplier. So in the manual, you could also find the continuous power provided by the manufacturer. So 8 is the overload power. It is the power excess of effective power than the rated power for a short period of time when the same auxiliaries are used under similar service condition for a limited period. So this overload power, sometimes, yan ang sinabi ko kanina, na pagbababaw ang tubig, no? Pagbababaw ang tubig, so ma-overload ang makina mo dyan. Kasi ikot na ikot ang propeller mo, pero dahil mababaw siya, ang thrust ng propeller sa barko ay nahihirapan. So kaya ma-overload ang makina. So ang probable causes diyan, kung masobrahan ka overload ang makina mo, there is a possibility of misalignment of crankshaft at yan ay napaka-major na trouble o napaka-major na problema kung mangyari. Kaya ang overloading ay iniiwasan kung maaari. Then halimbawa dito sa pagpaandar mo ng makina mo, halimbawa from slow ahead, slow ahead, then going to pull half ahead, and pull ahead. So by passing the critical area or critical moment, ingat ka dyan dahil kung hindi mo mabigla papunta sa half ahead ang makina mo, so may overloading dyan. So ma-vibrate ang barko mo. So kaya pagdating dyan sa critical period na yan, sa critical moment, kailangan mabilis ang pagka-thrust mo ng throttle para ang overloading niya para ang makina mo hindi mag-overload o hindi mag-vibrate critical din sa critical period na yan. So next is the number 9 is the minimum power. So minimum power guaranteed minimum or the lowermost power value by manufacturer for an approximate crankshaft RPM is the minimum power of the engine. So the total installed maximum continuous rating of the main propulsion engine should not be less than the minimum power line value, where the MCR is the value specified on the EIA-PP certificate. Engine maker has to follow IMO guidelines for determining minimum propulsion power for main engine, the maneuverability of the ship in adverse condition. So 10 is the stern output power. So the maximum power engine can generate when running in a stern direction at safe condition. So alam mo dito ko minsan, no, pag andar na makina, because naka-ahead ka, no, then pag ahead mo, naka-stop ang makina mo. Pag stop na makina mo, so nag-stern ngayon, atras ka. Pero hindi sinasabi yan na sa pag-atras mo, atras agad ang barko. So it will take more or less 3 to 4 minutes para magalaw niya ang barko. Umandar nga ang makina mo. Pero hindi niya bigla yan na maatras ang barko. So it will take time. Kaya kung minsan may mga pangyayari diyan na bakit nabangga doon sa nabangga doon ang barko, ang isang barko. Na nag-atras naman. Okay, nag-atras naman. Pero tingnan mo yan. Ano oras ka nag-atras? At gaano ang distansya mo doon sa isang barko na yon bago ka mag-atras. So kung malapit na ang ulo ang pruwa ng barko mo sa isang barko, ay nag-atras ka pero hindi na kaagad kumagat ang atras mo dahil may time limit diyan para na maka-atras ang barko pag-andar na makina. So diyan nagkakatalo ngayon ang bayaran kung sino nagkaroon ng kamalian. So on the astern output is the maximum power engine can generate when turning the astern direction at a safe condition. So the astern output power of the engine is always less than the output power in the ahead direction. This is because the propeller thrust add to the force of the rudder when going ahead. But in astern, the thrust is lost. Propeller blade section is designed for maximum efficiency in ahead. So in astern direction, the angle of attack is high on the back of the blade. Maximum, number 11 is maximum continuous rating or MCR for short. So it is the maximum power output engine can produce while running continuously at safe limit condition. It is specified on the engine nameplate and the technical file of the marine diesel engine. Important engine parameters such as specific fuel consumption, engine performance, etc. are delivered using the percentage of the maximum continuous rating of the engine. So equipment like VIT also work in the conjunction with the MCR rating of the engine to achieve better fuel efficiency. So number 12 is standard rating. This is the power output of the engine at normal service speed, which gives the highest economical speed efficiency, thermal and mechanical efficiency. This speed, the wear down of the engine is at the minimum rate. And 13, the power to weight ratio. Power to weight ratio is perhaps the most important criterion used when choosing the engine for type of ship. With ships becomes ultra large in size, BLCC. BLCC is very large crude oil carrier. ULCC is ultra large 20 KTEU ship, etc. Their heavy weight result in higher displacement equal lower speed. So by using equivalent horsepower in a smaller size engine compartment can be made smaller, allowing greater cargo capacity while maintaining high speed capability. Hence, to get the better and efficient performance from the ship, it is recommended to have high power to weight ratio. So last but not the least is the main propulsion power. So the main propulsion power means the total power supplied by a prime mover installed on a ship to provide propulsion. So it is not include the power unit integrated into the propulsion unit, which is not intended to provide propulsion during the normal operation. That is to say, the shaft-driven generators. So now let's go to the diesel generator fuel oil consumption per liter per hour. So, diesel generator differ from one another. May mga maliit, may malaki. And the table below outlined the approximate of the diesel generator fuel consumption per hour in liters. We've shown the usage of various load level across the range of generator from 10 kilovolt ampere to 500 kilovolt ampere. So we hope you can get a better idea for the generator efficiency by using these resources. So please note that the table should only be used as an indication only. Actual usage may vary slightly due to various factors. So ito, tandaan ninyo. So kung ang generator mo ay 8 to 10 o 8 kilowatt, ang ibig sabihin, 8 kilowatt ang generator mo, ang mga deliver niya ay 10 kilovolt ampere. So kung mga 1/4 lang ang load mo, 0.8 liter per hour lang ang konsumo niya. So kung half load ka, 1.3 ang konsumo mo, 1.3 liter. At kung 3/4 load, 1.8 liter per hour. At kung full load ka, ay 2.4 liter per hour. Kaya kung minsan magsabi ka, ilan ba na konsumo ng makina mo? So depende sa load mo. Kung ang load mo ay 1/2 lang, 1/2 of its full capacity, mababa ang konsumo mo. Pero kung full loaded ka, mataas ang konsumo. So that start from the 8 kilowatt to 10 kilovolt ampere up to 80 kilowatt to 100 kilovolt ampere. So look that in the 8 kilowatt engine or generator, ang 1/4 load 0.8 liters lang per hour. Pero pag nag 800 kilowatt ka na, 7.2 liter per hour ka na. So kung nag full load ka, 24 liter per hour. So ibig sabihin, kung medyo malaki-laki na ang konsumo dyan. Pero makikita mo itong mga tag 80 kilowatt na yan, doon na sa mga malaking barko. So kung mga barko lang nagabiyahe dito sa mga Asia, kung minsan makikita mo lang yan mga taga let's say for example, gaya ng mga 75 kilovolt ampere, so mga ganyan lang. So okay, yan ang tungkol sa fuel. Then punta tayo dito sa diesel fuel consumption chart. So this chart approximate the fuel consumption of the diesel generator based on size of generator and load at which the generator is operating. So please note that this table is intended to be used as the estimate on how fuel generator are used during operation and is not exactly representation due to various factors that can increase or decrease the amount of fuel consumed. So let's say there's a 20 kilowatt. As I explained earlier, there is a equivalent kung ilang galon ang konsumo niya. Then from 20 kilowatt up to 2,250 kilowatt. So kung 2,250 kilowatt ang makina mo, so ang konsumo niya kung full load ay 159 liters per hour. So ganyan, hindi para pareho na kaya sabi mo, ang generator namin, ang konsumo niya ay ganito lang. So that vary on the load and that vary on types of your generator as to whether or not your generator is bigger in size or smaller in size compared to the other generator being experienced by the other personnel. So now let's go to the bunkering. So bunkering may takes place offshore at the anchor or alongside. So during bunkering, it may be found from road tanker, bunker barge, or another tanker or ship. So whatever the provider, the procedure followed are similar. So during bunkering, it should be considered that high-risk operation is there. So where mistake can result in pollution and high financial penalties or even imprisonment. So ships burning heavy fuel oil in combustion equipment will, at sometimes in the voyage cycle, have to bunker fuel to replenish what has been consumed. One of the most important procedure of the bunkering operation is attention to the checklist. So therefore, a day before the bunkering, you should have a conference as to whether or not what shall be done and what should not be done. So the procedure unless form parts the company ship management system or SMS, which follows the International Safety Management Code. So the objective of the code are to ensure safety at sea, prevention of human injury or loss of life, and avoidance and damage to the environment, in particular to marine environment and to the property. So the bunkering checklist should be implemented to reduce the risk of negligence and other operational error. They must be followed in consultation with the chief engineer, as he is normally the designated officer in charge of the bunkering operation. So before bunkering, usually a junior engineering officer takes the sounding of the bunker tank and calculate the value of fuel available in every tank or fuel oil in the tank on the ship. When bunker plan is prepared for the distribution of the fuel oil be received. Now, here's the responsibility. The master is responsible for all the happening on the ship. The chief engineer should be responsible for matters that concern the engine room, including fuel oil system and bunkering. Taking fuel oil for bunkering is a potential high-risk operation, and therefore it should be under the responsibility of the chief engineer. See, this should be clearly stated in the company safety management system. If certain tasks are delegated, they should be monitored by and checked by the chief engineer. So the master should always be aware of these responsibilities. Now here is the case studies. A ship was bunkering in major Asian port. The bunkering operation was nearing completion, and had stopped to calculate quantities that remain to be bunkered in one tank being topped up. So the chief engineer was in his cabin and had delegated the task of bunkering to the junior engineer. So the junior engineer had not been on the ship very long. Bago lang siya. So the junior engineer made a mistake in calculating the remaining available space in the tank and asked for further additional amount for the bunker to be steamed. Due to the fact that the bunker tank was nearly full, heavy fuel oil bunkers spill out from the air vent pipe and into the water. So the authorities subsequently fined the ship and the master and imprisoned the master, chief engineer, and junior engineer. So yan ang mga bagay-bagay na kuminsan napaka-importante dahil ayaw mo sana makulong, wala ka namang ginawang kamalian, pero because of the negligence of the other party o kasama mo, yan, maaari ka makulong. So as far as the conclusion of that particular study, the company should ensure that the proper bunkering procedure are maintained. So the master should always ensure that they are satisfied that the bunkering operation are always carried out in a correct manner. So what are the essential to be to be carried out before and during and after the bunkering? So the following is the list of the essential to be carried out before, during, and after the bunkering. So bunkering plan. The bunkering plan is a piping schematic diagram that is accurate and representative of the bunkering system on board. So the plan should show the distribution of the bunker and is proposed by the bunkering station during bunkering and must be fully understood and signed by the officers involved in the operation. Ideally, it should show the amount of fuel on board the ship before commencing bunkers, the amount of fuel to be bunkered, and the plan of distribution of bunker with the tank sounding expected upon the completion. So a copy of the bunker tank sounding should be available to all personnel and form part of the bunker plan. Communication before commencing bunker. An effective and reliable means of communication is to be established and agreed between both parties. So the ship is to ensure that the agreed stop command and slow down command has been established with the bunker provider. So the most common means of communication during bunkering operation is by BSF radio. So the very high frequency radio communication between bunker station and the engine room is to be tested to ensure that noise from the machinery space does not interfere or block the communication from the deck and lead to misunderstanding. So there are headsets available on the market that have noise cancellation technology and are ideals for the engine room for deck communication. So there should be an agreed emergency stop signal available should the main communication fail with either party. So if the emergency stop signal is initiated, then the bunkering operation should be halted immediately. Some bunkering companies will place an emergency stop button like linked to the barge transfer pump by the ship bunkering station. This can be used by the ship officer in charge of bunkering should the need arise to stop bunkering barge pumping fuel. So ensure that this is tested. During the bunkering operation, the primary means of communication is to be regularly tested. So when it comes to ship bunkering, here are things to be done. Occasionally, ship trading to certain area are asked to bunker offshore. This is usually because the bunker are not available in local port or are of dubious quality or because jurisdiction impose draconian custom dues. So when asked to carry out ship-to-ship bunker operation, some further basic rules should apply and check should include. So one, the risk management. Two, the compliance with the oil company international marine forum guidelines. Three, the master being fully informed as to the operation including location, weather, fuel, rendering adequate, bunkering ships particular, and four is the confirmation that the bunker hose is in good condition and certified. Five is the bunker quality assessment. Six is the quality assessment shipboard oil pollution emergency plan or SOPIP equipment at the bunker manifold and wherever necessary as per the ship SOPIP plan. The SOPIP equipment should be kept in a state of immediate readiness to avoid the risk of an oil spill and pollution during bunkering operation. So SOPIP locker should have been minimum of this item. So what are the content of the SOPIP locker? One is the absorbent rule, two is the absorbent pad, three is the absorbent granules, four absorbent material, five boom, six is shovel, seven maps, 8 scoops, 9 empty receptacle, 200-liter capacity at least, 10 portable air driven pump, 11 oil boom for small spill containment, and 12 is oil spill dispersal. So this item must be stored in an easily accessible locker, clearly marked, and must be brought on the deck ready for immediate use prior to all bunkering operation. As previously mentioned, emergency stop procedure must be in place and all scupper plug, stable plug fitted to minimize oil fusion should be or should a spill occur. So here comes now the tank capacity. So the tank capacity should be monitored during bunkering by the use of sounding and or ullage. Sometimes it is easier to use ullage. So if the bunker tank is large, at the save and this saver time by not having to clean the large section of the sounding tape after its dip. Alam mo kung ano ang ullage? So ang ullage, let's say for example, ang dip ng tangke ay 1 meter. So pag naghulog ka, let's say for example, naghulog ka ng sounding tape mo, ang inulog mo ngayon ay 90 centimeter. 1 meter ang dip ng tangke na ilagyan mo na pula, 90%. Naghulog ka ngayon, ang nakuha mo ngayon doon sa hinulog mo nga 100 ay 5 centimeter. So, ibig sabihin, ang 5 na yon 95 ang ullage mo. Ang ibig sabihin, ang laman ng tangke mo doon ay 5 centimeter lamang. Pero ang ullage sounding mo is 95. So, unlike a dip sounding, pag nag-dip sounding ka, pag naghulog ka sounding tape mo, nakuha mo doon ang 5. So, yun ang reading mo, 5. So, dip sounding yun. Pero pag nag-ullage ka, hulugan mo ng let's say for example 1 meter ang capacity ng tangke mo sa 85%. Naghulog ka ngayon ng let's say 1 meter ang dip ng tangke mo na 80%, naghulog ka ngayon ng 90, nakakuha ka ng 2 cm. Ibig sabihin, 92 cm ang laman ng tangke mo kung ullage ang gamitin mo. So, just a moment. So, never use sounding pipe for ullage unless they have been specifically designed. For this, an irrelevant ullage table are used. Failure to use the correct table for the sounding or ullage may result in quantity miscalculation and consequently an oil overflow. So many ships have remote measurement systems that are safe, accurate, and are class approved. So the use of this remote system, however, should not be taken for granted as without regular maintenance and testing, and these pieces of equipment may give false reading because of this line blockage, air pressure failure, or transmitter electrical problems. Therefore, before bunkering, the remote reading should be cross-checked with a manual sounding, and this cross-check may be included in the ship's plug maintenance routine. Smaller ships may have tank gauge fitted directly on the bunker tank. So this gauge should be checked and calibrated every dry docking cycle to ensure that they are usually operational and accurate. So this may be in the form of the pressure gauge read out or a stainless steel tubing containing the bunker fluid with an external sight glass using magnetic indicator. the ship have a certain knowledge as to show pull the tank as to how the tank I mean how to pull the tank can be filled safely. So it is often normal to fill bunker tank to 90% capacity. However, it is commonly used 85% is okay. But kung gusto mo man dagdag pa ng laman o kinakailangan, so you should not exceed the 90% capacity. So some tank may require less due to unusual shape and internal configuration, which can cause airlock and pockets. So now here comes the so-called the bunker checklist. So what are the bunker checklists? Bunkering is a high-risk operation where mistake can have significant consequences, including fine and imprisonment. Often there is considerable command pressure on the ship and ship staff. Do not commence bunkering until everything is properly prepared, checked, and in place. So the bunker checklist is a very important document and is an integral part of the bunkering process. It is created as part of the ISM system and is ship specific. If it should be drawn up and approved by the chief engineer, and the checklist must be strictly followed and not just completely completed automatically. So on many occasions, items on the bunker checklist have to be checked off without verifying as to whether the requirements have been completed. This may well lead to serious bunkering incident. Bunkering is often carried out when the engineering staff are under pressure in respect to both time and manpower. So K checks are often missed and omission only come to life when it's too late. So what are the pre-bunkering checklist? So the pre-bunkering checklist were as follows. One is the state of adjusted water reviewed and deemed acceptable. Two, the ships properly secured unless it is ship to ship. Three, check the supply specification for the product corresponds to what was ordered. Fourth, agree quantity to be supplied and in what unit, either in cubic meter, in tons, in barrel, or etc. So agree the minimum pumping rate and the line pressure at the start, at the maximum flow, and at the end. Six is ensure that the bunker barge checklist is understood and completed. Seven, ensure that the bunker plan is understood and posted at the bunker station. Eight, emergency stop for bunker barge transfer pump at the ship's bunker station has been tested if supplied. 9. Ensure that the marble drip sample is clean and fitted. And 10. Check the correct bunker valves are open. 11. Cross-check correct bunker valve setup. 12. Fuel oil daily service tank at maximum safe working level and filling valve close. 13. The warning sign in possession, for instance, no smoking. 14. Material safety data sheet for heavy fuel oil is available. And number 15. SOPIP plan is available. 16. Spill cleanup material readily available. 17. Ensure all save all and draft tray plug are screwed in position. 18. Provision made to drain off the accumulation of sea or rainwater on deck during bunkering. By the way, in the 17, no, meron na line save all tank or drip tray. Yung save all tank or drip tray na yan, makikita mo may bin pipe sa tagiliran ng barko o sa deck. may bid pipe or doon sa may bunkering manifold. So doon sa ilalim niyan, may square doon na naka-fix. Yan ang tatawag na save all or drip tray. Para na in case of leakage, no, may fuel na nag-leak, doon maipon sa drip tray na yan. So number 19, plug all decks copper and ensure they are oil and watertight. Number 20, the foam fire extinguisher placed at the bunker station. And 21, the purifier and transfer pump are off. Number 22, check that the sounding and ullage piping cap are screwed down unless dipping the tank. Number 23, check that the air vent and flame arrestor for the bunker tank are intact and free from blockage. Number 24, reconfirm remaining space in the bunker tank to be filled. 25, check bunker tank high level alarm is fitted. 26, ensure that the designated overflow tank and overflow site gas alarm are prepared and monitored. 27, agreed start signal between ship and barge or the road tanker. So number 28, the Bravo flag flying and the red light showing at night. 29, agree emergency shutdown procedure. 30, ensure all fire precautions are observed. 31, all hot work permits should have been suspended for the duration of bunkering. Kahit ano pa ka-importante yan, but never do welding job or cutting job while bunkering. 32, check hose and coupling are secured and in good order. Fuel connection and hose secured to vessel. Number 34, check barge or road tanker plometer tamper seal and check sounding on the barge of the or road tanker. 35, carry out the spot analysis or compatibility test if ship has the test kit. 36, check on shipboard plometer. 37, ensure ship barge mooring will be tended during bunkering. 38, bunker manifold are open. 39, unused manifold connection isolated and locked off. 40, all ships communication confirmed as operational. 41, all ships to shore or barge communication agreed and operational. And 42, officers, watch, and masters are informed. And last but not the least, the signal pumping to commence is done. So those are the checklists that are necessary during bunkering. So let's go to the system setup or bunker system setup. So it is imperative that all engineering officers are fully aware of the fuel oil bunkering system. So the chief engineer should allow only engineers who are familiar with the system to be actively involved in bunkering operation. So the master should be fully aware during bunkering operation of the quantities to be received, the bunker distribution, the starting time, the officer in charge expected time of completion, and be in communication with all involved. So before pumping start, so the tank receiving the fuel should be identified by the officer in charge and the correct system valve open and tagged with easily identifiable valve position. All other system valves should be checked and tagged as being closed. So the system may then be cross-checked by another competent officers to ensure that it is in a state of readiness to accept fuel delivery. So it is recommended that this cross-check of the system setup is part of the bunkering checklist. So when commencing the bunker, ensure that the pumping rate is very slow to enable the system to be checked for leak and that the fuel is being received in a desired location. Once this has been verified, the pumping rate can be increased to the safest maximum rate, ensuring that the bunker line maximum pressure is lowered at and not exceeded. So during bunkering, here are the procedure. So during bunkering, you have to first witness the taking and sealing of the minimum of 3 representative product sample. So dito kung minsan sa sample nito may dayaan, alam mo bakit? Ang kukunin nila na sample dyan, yung wala pang tubig. Ang ibibigay niya sa iyo may tubig na. So yan kung minsan ang mga problema dyan lalo dyan sa Singapore. Sa Bangkok, ganun din. Nangyari sa akin dyan na 72 hours, walang alisan ang barko namin dahil pinalinis ko ang tangke dahil tubig, seawater ang bomba nila sa tangke namin. So next, the second is check the bunker line pressure regularly to ensure it is not so high. Third is check and record the temperature of the fuel as it is pumped on board. Fourth is monitor the fuel connection for leak and the fuel flow. Fifth is monitor the sight glass in the engine room to ensure that no overflow is taking place. Sixth is change over tank whenever necessary. Always open the other tank before isolating the whole one. 7. Check the rate of which bunker are received. Number 8. Check the tightness and slackness of the mooring rope. Number 9. Check the trim list of the bunker bars and the ship. And 10 is continuous monitoring and look out for the ship's position and mooring arrangement when at anchor. So here in the flow meter reading, here are the things that are very important. Flow meter is the circulation in the circulation line. So sometimes bunker barge flow meter are fitted with a small bleed-off line after the flow meter that return the fuel being bunkered to the suction side of the barge bunker supply line. So ibig sabihin doon sa may flow meter niya, nagabalik doon sa kanya ang naging supply niya na fuel. So this effective means that the fuel is being passed through the flow meter twice. So the bypass recirculation line may be only small in diameter, but over the bunkering period, it can have a big impact on the quality of the fuel bunkered. So what are the countermeasures? So check if any suspicious line after the barge flow meter. So use the ship's flow meter if fitted, cross-check and question any major differences. Ask to see the bunker barge flow meter calibration certificate and check that the flow meter seal is intact. So refer to the bunkering barge cargo piping diagram to assist with the checking of any suspicious line. So this is the cappuccino effect. So this is commonly happened in Singapore. Air is sometimes intentionally introduced by the supplier during the pumping of bunker to the ship, which irrate the fuel being delivered. So the common standard typolometer will not measure the quantity of the fuel being delivered, but the volume throughput. If the fuel has been aerated, this volume is made up of fuel and small air bubble. So thus the quantity of fuel being delivered is on some occasions considerably less than stated because the flowmeter, which measures the volume going through it, react to both the bunker fuel and the low density in trapped air and registered this as a large volume of oil. So the mass of the entrapped air, however, is so small that it does not contribute significantly to the total mass of the mixture. So when the bunker tank are sounded, the sounding also appear correct. All the entrapped air is to instill the suspension in the fuel. So when the air eventually settled out, so the fuel oil level of the bunker tank drop. So this indicates an apparent onboard fuel loss at the next sounding. Depending on the amount of bunker requested, the fuel shortage can be considerably or could be considerable and amount to heavy financial loss as a result of the bunker claim. So combating the cappuccino effect for the bunker, all you have to do is before loading bunker from the bunker barge, the following checklist should be carried out in addition to the ship bunkering procedure. One, the board the bunker barge and verify by sounding the barge fuel oil cargo tank and using the corresponding tank table the quality of the fuel on board the barge before bunkering commence. Two, if possible, obtain draft reading of the bunker barge before pumping begin. Three, check the sounding tape when sounding the fuel tank both on the barge during bunkering for any evidence of air bubble in the fuel. Next is ask to see the barge cargo pump that is used for the delivery and check for the strict air connection. This may be quite small, but this could have a considerable effect on the supply of fuel if you will not question them. So ask the crew how they intend to blow the line after completion of the bunkering and ask to inspect this arrangement before starting the fuel transfer to limit the opportunity to introduce air with the oil flowing. Next is to check the barge flow meter reading and confirm that the calibration certificate is for the meter in question and is valid, and confirm that the meter calibration seal is intact. Then check for the suspicious flow meter recirculation line. This may be small but can have a big impact on the quality received board. So during bunkering, monitor 30 minutes quality of the fuel coming on board by using the bunkering sample point. Check that the fuel for any frothing, which is indicative of air entrapment. So if frothing, ibig sabihin naga-bula-bula, it is suspected that the board that is suspected that board the bulb and ask to see the line blowing arrangement. If this has been used, it may be still be connected and the compressed air piping after the air isolation may have been pulled. This may be an indication that it has been recently opened. So next is after completion, board the bunker barge and verify by sounding the barge fuel oil cargo tank and checking the corresponding sounding table and calculate the quantity of fuel remaining on the barge. So difference from the initial sounding to final sounding should be good indication of quality of fuel offloaded from the barge. So if it is possible, obtain reading of the draft of the bunker barge after pumping is completed. So ask to see the barge draft table and roughly calculate the difference in draft from the bunker start to bunker completion and use the table to convert to tonnage. This will give a roughly measured of the quantity of fuel discharge. Now, ito ang napaka-importante. During bunkering, dapat maglagay ka ng thermometer doon sa malapit sa may manifold. So, paglagay mo doon, kasi may mga mostly ng mga bunkering barges, madaya. Pag tinanong mo kung ano ang temperatura niya, sabi niya kung anong temperatura ng seawater, ganyan din. So, if the temperature of seawater is 35, sabi niya 35 din. But don't believe. So, maglagay ka ng thermometer doon sa may manifold para malaman mo ngayon kung ilan ang temperature ng fuel. Kasi napakalaki ang diferensya dyan. Let's say, for example, 100 cubic meter ang fuel. Ang specific gravity ng fuel ay 0.951. 5, ganyan. 0.9515 at 15 degrees centigrade. Now, dahil tumaas ngayon ang temperatura, magkaiba ang specific gravity ng fuel. Yan. So, let's say for example, ang temperature rise multiplied by 0.0075 kung fuel at kung diesel ay 0.00065, doon makita mo ngayon kung ilan ang specific gravity at that particular temperature of fuel being measured. So, kung halimbawa ang 0.9515 at 15 degrees at nung makuha mo na ngayon ang temperature correction ay naging 948 na lang. So, ibig sabihin, ang 95 mo na specific gravity at 15 degrees, pag nag-0.88 na lang sa o 93 na lang siya pag na temperature correction factor mo yan. So may diferensya ka ngayon na kung mag-95 tons, kung mag-93 may 2 tons difference. So nalugi ka ng 2 tons out of 100 tons. So yan na napaka-importante na ang temperature mo ay malaman mo kung ilan ang temperatura ng fuel para ma-correct mo ngayon ang sa correction temperature sa temperature correction factor kung ilan ang natanggap mo. Hindi nasasabi lang niya na 35 doon sa temperatura ng seawater. So here comes the lest and trim. Sometimes the barge may have lest or trim and no correction table are available. So if there is no correction table available, it is possible that these circumstances, the trim or less, is to advantage to the supplier, and purportedly amount of fuel on board is more than that will exist. So the difference between the apparent and actual fuel oil on board can be considerable, especially if the tank have a large resurface area. Now the countermeasure is if no trim correction available, so before taking fuel oil delivery or gauging the tank, it may be prudent to make a written comment stating that no trim correction table were cited or are not available, and this can be countersigned by the bunker barge master para doon malaman na wala nga talaga siyang trim correction table. So, in kaso na may mga protest, may katuwiran ka ngayon dahil wala naman talagang lumabas na table doon sa kanyang pinirmahan. Now, when it comes to the temperature, ito ang sinasabi ko, the temperature of fuel is very important as it affects the volume delivered. If the declared temperature is lower than the actual temperature, this means that less fuel oil is actually delivered. For the supplier, gaining a few degrees centigrade means gaining a few tons. Water, let's say for example, if the 1,000 tons of fuel is bunkered and it contains 1% of water, So it is effectively just 990 tons of fuel. Kasi ang 1%, 10 yun, 10 tons yun. So a loss of 10 tons of fuel resulting from the water content is loss of approximately $7,000. So kung 10 tons ang nalugi ang hindi na-deliver sa iyo, kung ikaw ang receiving vessel, nagtubo ngayon ang bunkering barge or supplier ng $7,000. So biro mo yan, ang laki. So water may be mixed in the fuel oil just before the bunkering started. So seal sample are taken from the barge before the water is introduced and used as an official supplier sample. Yun ang sabi ko nina na kung minsan may mga supplier na madaya. Kukunin nila ngayon ang pure oil una. So pag nag-bunker na dahil naluan lang ng seawater ang bunkering barge nila, so tubo sila doon kung may tubig na. So ang ibigay nila sa iyong sample, yung pure oil para na wala silang pananagutan kung ma-analyze man, pure oil naman talaga ang binigay. Pero sa totoo lang, doon sa i-supply nila sa iyo, may halo na ng tubig. So another trick is to use water detecting paste. Pero kung minsan hindi mo rin nangyari sa akin yan, lagyan ko ng detecting paste. Pero minsan mahirap ano yan. Doon ko na malaman nung magkaroon na ng mga 10 cm, doon na hinaluanan nila ng tubig. Kasi sa simula na yan, hindi yung tubig ilagay nila sa iyo, bunker, para hindi mo ma-detect. So pag medyo nakabigay na sila ng let's say mga 10 cm or 20 cm, sa kanila yun ikaw-supplyan ng tubig. So yan, kikita sila dyan. Now upon completion of the bunkering procedure, so tapos na bunkering, after pumping is completed, the bunker supplier may want to blow the line through with compressed air to ensure that all the fuel is out of the line before disconnection of the bunker at the bunker manifold. So it is critical to be aware of the safety implication of this line blowing therefore. So all you have to do, you have to ensure that the pipe disconnection has not been commenced before line blowing. Huwag ka muna mag-loosen ng bolt and nut. So ensure that no system valve has been closed before line blowing. So take care of the vicinity of the bunkering pipe and it may move violently during line blowing. And be aware that during disconnection, a high flammable oil mist may be present in the bunker line caused by the blowing through action. And all safety precautions are to be followed closely after pumping and line blowing. The fuel quantity received must be checked and verified by using the method of such as gauges, sounding, usages, and kilometer. So whenever the chief engineer is satisfied that the quality of fuel received and the bunkering receipt has been signed by that officers or by the master, so the post bunker checklist is as follows. Ito bunker checklist after bunkering. So bunker valve close. Disconnect hose, drain, or blow through before disconnecting. So check valves, road tanker meter reading, and check ship meter reading and sounding for quality verification. Then if it is okay, then the bunker delivery set has to be signed by the chief engineer. And that's the end of the episode today. And now because sometimes may ginahaluan ko ng explanation ng iba at ang iba naman kung minsan gina-shortcut ko. So for those who wanted to learn more, so you can replay and take note of what was written in the screen. Kasi kung minsan doon sa gina-explain ko, minsan iba ang sabi ko kaysa nakasulat. So it's up to you to follow what was written in the or what you saw in the screen. I mean, which was written on what you saw on the screen. So thank you very much, and for the time being, dito lang muna tayo magtatapos at susunod Biyernes naman gagawa ulit tayo ng episode na makakatulong sa inyo kung interesado kayo matuto. Salamat at magandang gabi sa inyo lahat. Ako po si Chief Pinardien Lorque. Nagpapasalamat at magandang gabi sa inyong lahat. Thank you.